Hello, my name's John Miles and I'm with Sanden Sanco 2 heat pump water heaters. We're outside this beautiful 4-bedroom house in North Portland, Oregon, where the homeowner has decided today that he'd like to upgrade his existing electric water heater to a new Sanden Sanco 2 heat pump water heater. So about 25 years ago in Japan, there was a push towards a heat pump water heater. But it was a heat pump water heater with a difference. It used CO2 refrigerant to transfer the heat from the outside into the hot water. Since then, Sanden has successfully launched this product into the European marketplace, into the Australian marketplace, and about 5 years ago we came to the North American market. What we did is we put a lot of units into field trials across the US and Canada to make sure that the technology was translatable and worked across the US. And then we launched the product about 2 years ago. And today what we're going to see is we're going to see the installation of the Sanden Sanco 2 system in this home, replacing the 40-gallon electric water heater that we have in here. And you'll see at the end of the day that the homeowner will have hot water and be paying a lot less for it. The Sanden Sanco 2 is 4 times as efficient as a standard electric water heater, with the highest real-world efficiency in its class. The unit heats water faster, using less energy. The unit has the highest first-hour rating per tank size of any electric water heater. Rebates from utilities make the unit affordable for most household budgets. It can operate at almost any temperature the Northwest experiences. It works down to minus 26 degrees and below Fahrenheit. Virtually no homeowner in the Northwest will ever experience a lack of hot water due to a cold temperature outside. The split system allows the device to be installed in locations where other heat pump water heaters may not fit. Also, since the compressor is outside, you don't have to worry about cold air exhaust, condensate lines, and compressor and fan noise inside the home. The Sanco 2 is an improvement on standard electric water heaters. Standard electric water heaters rely on a heating element installed inside the tank. When in operation, this element heats up the water, which then rises to the top where it's used. This results in a constant inefficient churning of different temperatures inside of the tank. In a Sanco 2 unit, there's no heating element inside the tank. All heat is generated in the heat pump that's installed outside. Cold water enters the bottom of the tank and is pulled through the pipe into the heat pump. There it is heated with the CO2 refrigerant and the heat from the outside air and sent back to the top of the tank. Cold water is pulled from the bottom of the tank. Hot water is then pumped back to the top of the tank. This causes stratification of the two water temperatures inside the tank, helps maintain an average tank temperature that is higher than a normal water heater, and also allows more hot water inside of the tank. The CO2 refrigerant system is entirely self-contained. Installers and users do not need to interact with the CO2 or any part of the pressurized heating system. CO2 refrigerant has a minimal impact on global warming. It's uniquely used in the Sanco 2 with a much lower global warming potential compared to synthetic refrigerants. And because CO2 is a natural refrigerant, it will not deplete the ozone layer. Hey Ryan, John Miles with Sanden Sanco 2. How are you today?
Good, nice to meet you.
Nice to meet you. So, walk me through what we're going to do today.
Absolutely. Well, we met with Derek, the homeowner, and picked a spot in his backyard here that would be kind of out of the way, but also a really good location for our plumbing lines and our electrical runs. So we're at the corner of the house here. We've leveled the ground a little bit already, and we're ready to set our clad light pad and get the unit placed on top of it.
Beautiful. This looks like a really nice spot. Clearance is behind. I need about 6 inches to the house wall there, and in front around about 12 inches, but we have the whole expanse of the yard on here.
No, it's a great location, and it should be a pretty easy run for us to take our plumbing lines just around the quarter through the rim joist and into the house.
Okay, and electrical? How are we going to do that?
Electrical, we'll do about the same thing. The service panel is just on the other side of the wall here, and we'll run the electrical out the side as well. We'll get a disconnect box, and then we'll run a whip into the unit and get all powered up.
Once you've selected a location for the outdoor unit, we recommend placing a pad on the ground to mount the unit on. Various types and sizes of pads are available for purchase. Ensure that the pad is leveled and located so that it maintains the clearances as required by the installation manual.
I'm good. I'm within bubbles, I'm good. Okay. Cool. Good.
Beautiful, guys. Now don't forget, installation instructions up on the top there for you. And in the box, super important, there's adapters and also the condensate connection in here. So don't just toss the box in the trash. Before you do that, take those connections out for us. Okay, Joe, what we're going to do now is the unit actually is going to blow cold air out here. So it's going to take moisture out of the air. So it will actually drop water down. So in your hand, you've got a little condensate drain, and we're going to pop that in on the bottom of the unit there to allow us to drain that away, and it'll be great water for the homeowner's plants. Greg, how are you?
Hey, John. Good to see you.
Excellent. So this is the old existing electric tank. So I think we're going to decommission this, right?
Correct.
So how are you going to do that?
So first, we want to shut the power down, shut the electric utility off to the tank. Then we want to shut the water supply down to it, and then drain the tank so we can move it out of here.
Yeah, now this is a glass line tank, and we're going to replace it with a stainless steel tank, which is going to weigh around about half the actual weight of this
Yeah, I was
unit.
happy to hear that. Yeah.
So that's going to be good news for us. And then here we've got the hot and the cold from the home, right? Correct. Now, I understand that the homeowner in this case actually wants to move the tank for some slightly better location. Right. So you're going to have to do a little bit of extra plumbing work. But if we didn't want to move it, it would be pretty straightforward, right, to make the connections into the home?
Oh, indeed. Yeah, you would just literally just tie it right back into how it was existing. So you don't really need to modify anything.
Okay.
Just go from the Sanden unit to the existing hot and cold water line.
Yeah, so that sounds pretty straightforward, realistically. So shall we get on with it?
We should.
What we're doing here right now is we're putting in the piping from the tank to the heat pump. So you have a cold water line coming from the bottom of the tank that brings cold water to the heat pump. It gets heated using the outside air, and then we're going to send it back into the tank using that hot return line. So what we're doing right now is setting up. We've made our penetrations into the home. We've actually drilled a couple of 3/4 inch holes there for the two pipes to come in and out, and now we're setting up to be able to make those final connections into the building and then come across to the tank. You can actually run these units with a pipe length of 50 feet between the heat pump and the tank in one direction, so the cold line can be 50 feet and the hot line can be 50 feet. That allows maximum flexibility when installing the heat pump in a system, and where the tank location is to get you the domestic hot water as best you can on these units. You'll notice that the piping is 1/2 inch between the heat pump and the tank. We use that because we want to keep the velocity nice and high and allow our pump to get the maximum flow through the system that it wants to do on there. So very important that you keep it 1/2 inch. Don't upsize it, don't downsize it. Stay with the 1/2 inch that we calculated. As we can see, we're making those connections inside. The next step is going to be to look at the electrical, which is going to come onto the outside of the home here.
All right, John, let's take a look at the service panel.
Okay,
So
great. Well, I see the breaker box here. Let's pop her open and see what we have. So right here, I see the old wire for the water heater was on a 30 amp breaker. We actually can go down to a 15 for us. So a 15 amp double pole breaker will go in here, just replacing that 30 amp. But the one thing that we're going to need to do is to actually bring this to the outdoor unit, not to the tank on this particular system.
Correct.
So makes it a little bit easier for you, super flexible, because you only need to come out to follow the pipes outside and away we go. And obviously then we can move on from there. Then the other thing we're going to have to do is the thermistor wire.
Yeah, we've got that 16-2 shielded wire that's already out on the outdoor unit. We'll trace that back into the tank, and our electricians will land that on the tank, and that's the communication between the outdoor and indoor unit, correct?
Yeah, essentially as you use hot water out of the tank, that thermistor is going to make sure and measure that water temperature, and then if the tank starts to get cold, it's going to bring the heat pump on and make all that lovely 4.5 kilowatts, the same amount of hot water you got out of that electric water heater. Wow, Greg, you've really got on with this one. Now, one of the things that we see is that we've been able to really push this up against the wall, which is great because, you know, part of the great thing about the tanks that we use, we have very small clearances for these things. So that's a great, also helps with that flexibility of that installation for you as well right there. So walk me through the piping a little bit here. So what do I have?
So here we have coming down, we have your hot and cold potable water lines. We have the cold water will come down. It'll feed into this thermostatic mixing valve, which I'll explain in a minute, and then it'll keep going down to feed the bottom of the tank. So what this does, it's a thermostatic mixing valve, is it mixes the hot water in the tank with cold water coming in to whatever your desired temperature is. So, typically code is 120 degrees water coming out of your taps. So this device tempers the water down to that temperature because the water in the tank may be higher than 120 degrees.
Yeah, certainly, because the Senko 2 can actually make 175 degree hot water.
There you go, yeah.
Some of the benefits of making that hotter water is it allows more energy to be captured inside of the tank. And that means if you're a high water user, you can actually get more hot water out of these units. So the mixing valves, it has two benefits. One, prevents you from being scalded, and two, allows you to get a bit more hot water out of these units as well. Mm-hmm. So what's next on the agenda?
So next we're just going to connect the dots here. We're going to bring the cold water back down into the tank. We'll provide a shutoff, and then after that we're going to bring the water lines from the outdoor unit to the tank here, so we can make that heat transfer from the outdoor unit to the indoor.
So now we're adding 3/4 inch pipe insulation along the exterior pipes and also the valve connections on the outside of the unit. We do this for a couple of reasons. First, it keeps heating and energy inside of the piping. We're making 150 degree hot water. We don't want to lose any of that energy to the outside air. Secondly, it gets cold in Portland, and we have occasions where the temperature does drop below freezing. Although we're not installing it on this system, there are heat trace packages available for the system. The heat trace is a small electrical wire that is wrapped around the pipe to keep it from freezing. The system itself also has a freeze protection program built into it that will look after itself during cold weather. If the power supply is out, you can also drain the system manually. The system can be supplied with an optional power outage package that can be included to automatically drain the unit in the event of a power outage. So Ryan, I see we've got the electrics almost finished here.
Yeah, we're about ready to close up the disconnect box. We've got the line of load side in place and conduit running down the wall and over into the back of the unit.
Then I see we've also got the thermistor cable running back down, and that's going to connect us to the tank, right?
That's right. We've got that back through the wall here and through the rim joists, and electricians should be wrapping up inside right now and getting ready to tie that into the tank.
All right. I noticed that you haven't actually fully powered up the unit yet.
Yeah, we do not want to power up the unit until we've got water in the system.
Yeah, that would not be a great thing, right? Because the temperature sensor would sense the cold water in the tank or even the air temperature and say, hey, it's time to turn on, and try and fire the unit without any water inside. I think electrical pretty much wrapped up. Final connections to be made at the tank for the thermistor, and then final connections on the plumbing side.
That's it.
Per code, a local fuse disconnect must be installed adjacent to the heat pump unit. In the disconnect box, the 208 to 30 volt power wiring and the ground wire from the breaker box is connected to the line side of the fuse. The load, or the other side of the fuse, is then wired directly to the heat pump. The ground wire is then connected to the ground wire connection on the heat pump. In this installation, a separate 115 volt power outlet is wired into the system also. So here we see the connections actually into the Sanden unit, L1, L2, 208 volt, 230 volt, single phase, and then all important ground on here. So making the connections at the terminal box, and you can see the flexible whip that's coming down off the conduit. So everything looks good in here, and we just need to pop the final cover on to finish off the wiring on the power side to the outdoor heat pump. Wow, Greg. I mean, every time I come down here, the plumbing just keeps getting better and better.
Thank you.
So I see we've actually got piping going out to the heat pump now.
Yes. Yep, it's complete. We have the lines going, coming from the heat pump. This is the hot line coming back from the outdoor unit. Circulates through, travels back to the outdoor unit for the heat exchange through here, and you know, here we are.
Well, turning her on,
This
putting water to the system.
We're in action now.
One of the other things I don't notice, we don't have an expansion tank on this one.
Right. So an expansion tank is necessary when when it's more of a closed system and there isn't anywhere for the expansion to go, because as we all know, when you heat water, it expands. So in this system, there are no check valves or one-way valves in place. So as the water is heated and expands, it just kind of dissipates through the system, and there is a place for it to go. So since we don't have a closed system here, there's no need for it.
This is what we call an open system, right?
Yep.
So, excellent. We look great. I think we're all pretty much ready to rock and roll, and looking forward to making some hot water, right?
Indeed.
So, Ryan, we're almost at the moment of truth, right? Because we've piped the unit, we've piped the city side, we've filled the tank up with water, we've opened up the valves from the tank to the heat pump. All that remains now to do is two things. One, bleed the heat pump.
Yep.
So there's air inside these two lines, and two, put the power on. So the first thing we're going to do is open up these two bleed screws. Now the top one first, right? So what you're going to do is you open it up until you've got a nice steady stream of water. You see that there's a bit of air in there.
You can hear it as well.
Right, hissing out. Now you're getting a nice steady stream of water. Now open up the bottom one. Right, and you're going to see the same thing.
Yep. Trying to get you wet.
Yeah, right. Always an occupational hazard, right?
Yep.
You know, as it forces the air out of the system on these. So get it nice and open. There you go. So it takes a little bit of a while. You'll be surprised how much air there is actually in these systems. And some of that air is also built up inside the piping as well on here, right? So I think what we're seeing now is we should be seeing fairly steady stream of water.
Yeah, absolutely.
On both sides.
Yep.
Okay, so let's close up those pipes, those bleed screws.
All right, let's turn the power on.
Great, that's excellent, Ryan. Now, one of the things that you'll see is nothing happened, right? And the reason for that is there's a 3-minute time delay built into the system for the system to actually work out all of its kinks, talk to the heat pump, talk to the tank, and various things like that. So after about 3 minutes, we should see the fan kick on because the tank of water is cold, and then the heat pump will kick on after that. The compressor will start. When we do that, we can actually start then to set up the unit. We can set the time on the controller, time of day. That enables the homeowner, if he wants to schedule his hot water, he can do that. And then we can also set the water temperature. Right now it's at its default setting of 140 degrees from the heat pump into the tank. We may want to turn that up. Typically we would run these units at about 150, maybe 160, but 150 is kind of that big sweet spot of efficiency plus performance.
Can the homeowner see any of that from out here on the unit?
Yeah, on the end here he can see the display of the signal, the system, and he can do that as well. He can take a look at that if he needs to.
Should we pull the cover so we're ready to do that?
Yeah, sure, let's do that.
Sounds good.
There it goes. So Ryan, nice job.
Yeah, thanks. Looks good, right?
Yeah, beautiful.
Can't even hear it.
She's running.
Yep.
Making hot water, which is great. So tell us a little bit about the tools that you used today.
Well, we used everything from torches to sweat our copper in place to some PEX tools for our PEX piping, and then just hand tools, a crescent wrench, and some other hand tools to kind of accomplish what we needed to. Not too complicated.
Yeah. So actually, no special tools, really. No.
No, really, nothing too crazy at all for the install.
That was great.
Yeah.
And how about the permitting process for this unit?
So for any process permitting this, you're going to get a plumbing permit, you're going to get an electrical permit. And so you're going to have both the new circuit that's been put in and then the plumbing work that's been done inspected. So the city will come out and inspect both of those items, sign off, and the homeowner will be all recorded and in good shape.
Yeah, great, because I mean obviously there's we look at the quality of the work, everything's in conduit, and there shouldn't be any problem whatsoever.
Just need the jurisdiction to sign off, that's it.
Beautiful. So I think a job well done. And I'm sure the homeowner will be ecstatic to have hot water. The unit's making hot water right now, and you'll come home and be able to take a nice hot bath.
Yeah, thanks for your help today.
Hey, no problem. Thanks a lot.
Thanks.
With the Sanden Sanco 2 system, It's actually designed to be a very low maintenance piece of equipment. With the outdoor unit, all that we need to worry about is the fact that we need to keep the outdoor unit clean, just like you would do with any air conditioner that you have at home. So if you see some excessive, debris and leaves and stuff like that on the back of the unit, just brush them off or spray them off on those. The tank is stainless steel, so it doesn't have what we call any anode rods. Anode rods are designed to help your tank live a long time and are supposed to be changed every once in a while. But because we're stainless steel, we don't need that. So the tank really is maintenance free and lasts for around about 15 years, and that's how long we warranty it. The heat pump itself is warranted for 10 years, and that includes 3 years of labor. Though if something goes wrong in the first 3 years after installation, we'll pay for somebody to fix the unit for you. We've seen today that it's actually pretty straightforward to install a Sanden unit. There are some small pitfalls though that people can get into. A couple of things. Everyone always asks us, can we use a different tank? And the answer is no. Sanden sells a range of different gallon capacity tanks to suit pretty much every household. And the tank is actually specially designed to maximize efficiency, reliability and performance on the system. So it's unfortunately something that we're very firm on, and you can't use a different tank on these style systems. Other things, connections have to be per the manual, 1/2 inch to the heat pump. Don't upsize the lines and make them a different size on there. Make them always the 1/2 inch. Connections to the house can be 3/4. Power supply, as we saw today, 208, 230 volt. It's a double pole breaker, which is another common little error. People seem to think that a single pole breaker can get away with these units, but double pole. Other than that, it's very straightforward. It's just a case of joining dot to dot to dot, following the manual. Don't turn the power on until the system's full of water and bled out. And other than that, you should be very happy and excited to have your hot water heated by a natural refrigerant, using the outside air and doing it at a extremely high level of efficiency.
For more information and the location of your nearest Sanco 2 distributor, please visit our website www.sandenwaterheater.com.